Morning, everyone. I request Himanshu sir to conduct the session.
Good morning, everyone.
Good morning, sir.
Is my screen is visible? Is this visible?
Yes, sir, it's visible, sir.
Okay. So in the last class, we have discussed about the VBT. Students, so have you revised it? We have postulates of VBT. Just I'll revise it in a quick way so that we can continue with the rest points. Okay. First point was based on the overlapping of the atomic orbital. It means the orbitals which are half-filled, they go for the overlapping, and then they only form covalent bond. Second was the type of orbital, only half-filled orbital to form covalent bond. If one of the orbital is fully filled or one of the orbital is not having any electrons, then there is condition where no overlapping takes place. Third one is the spin of electron. See, for the covalent bonding, one of the spin must be clockwise, another must be anti-clockwise. If both of the spin is clockwise or anti-clockwise, there is no covalent bonding and no overlapping of the orbital takes place. Well, go for the fourth one. If the condition is orbital retain their original identity even after overlapping. Even after the overlapping, what exactly happened? There is no change in the shape of the molecule, no change in the shape of the atomic orbital. There is no change in the property, so it retains its original identity. And fifth was, it tells about the electron bond. For example, one unpaired electron is present, then single covalent bond. Two unpaired electron is present, double covalent bond. Three unpaired electron is present, triple covalent bond. Okay. Then sixth point was intensity of the overlapping. That is, overlapping should be take place at the optimum position. It means the condition of the minimum repulsion. Every element try to occupy the minimum repulsion position so that it can get the maximum stability. Okay, so the nucleus must not be close to each other. If the nucleus and nucleus will close to each other, that it means that the repulsion between the atomic orbital will be maximum. Okay, so these were the 6 points we have discussed in the last class. Let's start with the 7th point. Okay, the 7th point is the extent of overlapping. Extent of overlapping decides bond energy, bond strength, and third thing you can say bond length. So if overlapping is more, it means overlapping is increasing, it means the bond strength will increase. You have to remember this only. Okay, so if bond overlapping is more, just imagine one atomic orbital, another atomic orbital, one atomic orbital, another atomic orbital. Okay, there's a structure 1A, structure in B. Just tell me in which condition the bond strength will be more, bond energy will be more.
B, sir.
B. Why? Because according to the VBT, I told you that the more overlapping will be there, then more strength will be there. And if more strength will be there, it means the bonding between the two atomic orbital is maximum. Okay, not exactly the bonding, the overlapping. Okay, eighth thing, there is sigma, that is like you have to make it like this, and pi bond. Okay, So basically, two type of overlapping takes place. Two type of overlapping. Do anyone know what is two type of overlapping?
End-on and overlapping and
Side
lateral.
by side and end by end.
Okay, first one is axial. Axial, you can say head to head. Head to head sort of overlapping is known as axial. While I'm talking about the parallel overlapping, you can say side to side. So by head to head overlapping, there is a formation of sigma bond. By side to side overlapping, there is a formation of pi bond. Clear? Head to head, just like s orbital. This is a head to head overlapping. P again, this is a head to head overlapping. But if I'm talking about the parallel overlapping, then it is like this. See, side by side, if the orbital are overlapping each other, it means that is known as parallel overlapping, or you can say pi overlapping. You can say side by side overlapping, whatever you want to say. So the exact, I told you the name. Axial overlapping, it means when there is a head on head overlapping, that is called axial. Okay, which one is more? You can say more overlapping and more strength, sigma or pi? Which one is having?
Sigma. Sigma. Sigma.
Sigma. Very good. Just remember this thing. Sometimes it happens like which one is more, which one have more strength. So you have to remember that sigma is having more strength. Okay. So if I talk about the significance of these orbitals and the atomic orbital signs. So first condition is only plus will overlap with the plus orbital. Yeah. Minus will overlap with the minus. First condition is either plus will overlap with the plus, minus will overlap with the minus. There is no plus minus overlapping. No plus minus overlapping will be there. Second condition is this plus and minus is not charged. These are not charges. What are these? In case of s orbital and in case of p orbital. S orbital plus means what? Electron density above internuclear axis. And minus represent electron density below internuclear axis. So two conditions for s orbital. Plus one is the electron density above the internuclear axis, and second is negative sign for the electron density below the internuclear axis. In case of p orbital, we have, that p orbital have a dumbbell shape. Okay, so in case of p orbital, plus sign represent the upper lobe and negative sign represent the lower lobe. Clear?
Yes, sir.
Okay, so if it is clear, just tell me in which condition the possibility of overlapping will be is there. Okay, normal thing. Okay, two conditions are there. In which condition overlapping is possible?
Second
First
condition,
one,
sir.
sir. First one.
Second,
First.
sir.
No, in the first point I told you, plus will overlap with the plus, negative will overlap with the negative. No plus minus overlapping is there. The plus minus is not charged. See, if it is about the plus minus charge, it means we are talking about the electrostatic force of attraction. But right now, I'm not talking about the electrostatic force of attraction. It is just because it is just the upper lobe and the lower lobe of the P. See, this is the upper lobe, this is the negative lower lobe. So upper lobe shows the plus sign and the negative shows the minus sign. That's it. So in this case, if you'll see, the one who said the first one is correct, but while the one who said the second one is incorrect. Why? Just because in upper lobe there is a possibility that the plus of this will overlap with the plus of this orbital. While in this condition, plus and minus, minus and plus, so there is no overlapping. Overlapping is only possible when same sign is there, plus plus or minus minus. If plus minus is in together, then the overlapping is not allowed, or you can say it is known as negative overlapping. This one. This one, in this case, it is known as what? Negative overlapping. Clear? Which is not allowed exactly, okay? Okay, just tell me one more condition. Condition A, condition B. Okay, now.
A, sir. A, sir. Sir.
Clear? A?
Yes, sir. Yes, sir.
Why?
Because there are
Six.
positive and
Positive,
overlapping.
Plus,
Yeah.
plus overlapping.
Plus will overlap and plus minus cannot be overlap. Good. Okay. So, okay. This answer me fast, huh? This is condition A. This is condition B. Okay. Which kind of bond will form in condition A?
Sigma.
Sigma or pi?
Pi bond, sir. Pi bond.
Pi bond. Why?
Parallel overlapping.
Parallel
Side by
overlap.
side overlapping.
Or side by side, you can say. Okay. While in the condition B?
Sigma bond. Sigma bond, sir.
Sigma bond, because P and P are. Okay, good. Okay.
Can
Let's.
you
Yeah.
for p orbital and s orbital overlapping?
P and S. See,
Yes,
S
sir.
is spherical in shape, and P orbital can overlap like this only, because S is a non-directional bond. So it will be okay. Now this condition is known as what? I'll go for the SSSP, PP. I'm telling you every overlapping now. But if I talk about the S and P overlapping, then it is a sigma bond. S never do side by side overlapping. Okay.
Yes, sir.
Okay. Let's go for the type of bond. First one is I'll talk about the sigma. First of all, I'll go for the sigma bond. Sigma bond, we have to study S and S, S and P, P and P. Three conditions are there. SS, SP and PP. So if I'm talking about the first condition, that is S and S overlapping, it means one S orbital of one atom, S orbital of one atom, they will overlap and form what? Forms SS overlapping.
Sigma
For example,
bond.
I'm talking about the hydrogen atom. If I talk about the hydrogen atom, hydrogen configuration is 1s1. Another hydrogen atom configuration is 1s1. How many of you know how to do configuration? Everyone knows it?
Yes, sir. Yes, sir.
Yes, sir.
Okay. So hydrogen atom, the configuration is 1s1. So one orbital of hydrogen, that is this. Another of another hydrogen, that is this. So see, they both are in the positive spin right now. So I told you there is a possibility that they will do overlapping. So this orbital will overlap with this orbital will overlap with this. S only have a spherical shape. S only have a spherical shape. So S and S, they both overlap and form what? Sigma bond.
Sigma bond.
And now the molecule is considered as H2 molecule. So there is a SS overlapping. Clear?
Yes, sir.
Okay. Let's talk about the SP overlapping. See, I'm talking about the example of HF. Hydrogen. Hydrogen.
Fluorine.
Fluorine.
Configuration. Fluorine configuration.
The
The
hydrogen.
1s, 1's hydrogen.
What? 1s1. Yeah, 1s1. I'm talking about configuration of fluorine.
1s2, 2s2,
What is the
2p,
atomic number of fluorine?
9.
9.
So if I'll do the configuration, it will be 1s2, 2s2, 2p,
It will be 5.
5.
2p,
5.
5.
5. And
5.
how many electrons can be occur in, is possible in p orbital?
1 unpaired.
1, sir.
One unpaired, but how many? Total number. How many electron can come?
9, sir.
9.
6, sir. 6. 7.
2
Okay,
is
sir.
to
You're asking about the
2p5.
valence electron.
See, in s orbital, you can say only 2 electron maximum, p6, d10, and f14 maximum
14.
electron. Okay,
Yeah.
so in 1s of hydrogen, that is this. If I'm talking about the p orbital, according to Hund rule, we have to first fill one electron in the each orbital, then we'll go for the pairing. So since we have 5 electrons, 1, 2, 3, 4, and 5. So I filled the 5. So you can see that p orbital have 3 x6,
Unpaired electron 1.
py, and pz. In pz, you can see there is one unpaired electron. Yeah, the one who is saying that there is an unpaired electron, you can see that now this hydrogen will overlap with the pz orbital. Okay, so p, if I talk about the shape of the p, see, hydrogen have s like this, p orbital. This is px, this is py, or you can say pz. But right now I'm making pz like this. This is px is fully filled. Py, it is fully filled. Pz have only one electron. So now this sigma bond will form. Why? Because there will be a overlapping between this 1s and this p orbital. And now when they overlap with each other, they will form a bond like this.
Sigma bond.
A sigma bond will form. And the rest orbital will remain as it is with the electron field. So now the bond is known as sigma bond. So this is a sort of pp overlapping. Clear?
SP, sir.
sp, sorry. I think, I don't know. My brain is not working, I think. I'm doing a silly mistakes. Okay. So this is a sp overlapping when the 1s orbital of the hydrogen and 1 p orbital of the fluorine, they are overlapping and they are forming what? sp overlapping, and the bond is formed is known as sigma bond.
Sigma bond.
Okay, let's go for the pp overlapping. See, if I'm talking about the molecule of fluorine, I'm talking about F2. Okay, so atomic number of fluorine is 9. Configuration will be 1s2, 2s2,
2p5.
2p5.
5.
Another fluorine 1s2, 2s2, 2p5.
5.
So I'll take only this orbital and this orbital. Okay, so p, px, py, pz. 1, 2, 3, 4, and 5. One empty orbital is present. S is fully filled, another one S is only. Oh, theirs are again fully filled. If I'll go for this one, one S is fully filled, 2s is fully filled. While if I talk about the p orbital, again px, py, pz, 1, 2, 3, 4, and 5, one unpaired electron present. So it means one unpaired electron fluorine of each fluorine is you can say unpaired. One unpaired electron is present in pz of each fluorine. So now if I'll make this orbitals, so this is px, this is py, and this is pz. And again of this one, px, py, pz. Px is fully filled, py is fully filled, px is fully filled, py is fully filled. Which one will overlap?
PZ, sir.
pz.
PZ.
In pz, this is z. This is my z. Z have one unpaired electron. So what will do? They will overlap with each other like this. Okay, you want this PDF? Whatever I'm writing here.
Yes, sir.
Okay, I'll do one thing. After finishing this sigma and pi bond today, and if possible, before hybridization, okay, I'll send the PDF. Okay.
Okay, sir. Okay, sir.
Okay. So this one is only about the sigma and the pi bond, sigma and pi bond, but only sigma right now. Just tell me which kind of bond, sigma or pi here, F2.
Sigma, sir.
Sigma bond, sir.
Okay, we'll go for the pi bond and that hybridization and all. Okay, so characteristics of sigma bond. Okay, if I talk about the characteristics of sigma bond, first thing you have to remember, this is the strongest bond. If I compare sigma and pi bond, there is maximum overlapping takes place in the sigma bond. So in this condition, maximum overlapping takes place. So if maximum overlapping is taking place in this bond, so it means it is the strongest bond as compared to the pi bond. Second thing is electron density. Electron density in sigma bond is symmetrical. If there's something is symmetrical, it means the maximum possibility of getting the stability. Third thing, free rotation. See, if I talk about the sigma bond, both the atoms, they can rotate on their internuclear axis easily. Okay. Fourth one, strength. If I talk about the strength of sigma bond, PP is having the maximum strength, then SP, then we'll go for the SS. Next one, fifth, that sigma bond may exist either alone or with the pi bond. There's a possibility sigma bond may be alone or maybe with pi bond. Okay. And last one is the unhybrid orbital, which are not having the paired electron. Unhybrid orbitals involve in sigma bond during hybridization. Okay, so whenever we are talking about the hybridization, then pi electron do not participate in the hybridization. Just remember this thing. At the time of hybridization, pi bond don't take part. Only the sigma electrons are counted. Okay.
Sir, SS overlapping is greater now, sir.
in which in the first point I told you that
The fourth point.
the strength of sigma bond. Na? So PP in case of sigma, I'm talking about the sigma. The extent of overlapping in the case of PP side by side in PP. This condition. So this is a sigma bond. So in this condition, the strength is maximum. This is because the extent of overlapping the PP orbital is maximum.
Okay, sir.
Okay. Next one. Let's take an example of pi also. Let's take an example of pi. Pi means which kind of overlapping? Lateral. Yeah, you can say side by side, or you can say parallel. Okay. So when P and P orbital, they are combining parallelly. They are forming what? They are forming what?
Pi bond.
Pi
Pi.
bonds.
Okay. In case of oxygen atomic number is
8.
8. 8.
then I ask atomic number. Just try to remember the period table as soon as possible. Just because. Okay, configuration. I'll explain it later. Configuration 1s2.
1s to 2s to 2p
2s2 2p4.
1s2 2s2 2p2. Okay. Then 1s2
2p4, sir.
2p4
2p4, sir.
2p4. At least you guys are not sleeping. Good. Okay. 1s, 2s, 2p1, 2, 3, and 4. How many unpaired electron?
2 sir.
2.
In same condition, if I'll go for this one, 1s2, 2s2, 2p4. Okay. So now in this case, what will happen? These two orbital will overlap with each other. But what kind of overlapping it will be there?
Sigma and pi.
Yeah, one will form the sigma bond and one will form the pi bond. Okay, just remember one thing. I'll give you one question then. If sigma bond is, if only single bond is present, then it is sigma. If double bond is present, one sigma, one pi.
Pi.
If triple bond is present, one sigma and two pi bond.
2 pi.
Clear?
Yes, sir.
Yes sir.
So should I give you one question?
Yes.
Yes sir.
Okay.
Sir.
In case of CH3CN, cynomethane or methyl cyanide, whatever you want to say, just calculate the number of sigma and pi bond fast. Done?
So is it 4 or 5 sigma bonds?
Okay, you tell me your answer. You tell me your answer.
So I think 5 sigma bonds and
Sigma,
2
according to you, is 5 and pi is how much?
2, sir.
2. Okay. Let's open up this structure. CH3HHHC triple bond N. Sigma, 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 pi, pi. Okay. Done.
5
Correct.
sigma bond,
5
2
sigma
pi
bond and 2 pi bond.
2 pi bonds.
Okay. One more question. CH2 double bond, CH single bond, COOH. And another example, C2CN whole 4.
6 pi bond, 3 sigma bond.
Okay. According in first one, how many sigma?
Sigma bond 6,
Okay. Pi bond
3.
3. Okay, let's go for the first example. C, H, H, C, H, double bond, single bond C, double bond O, single bond O, H. Okay. Sigma, 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 and OH bond is also there. Sigma. 1, 2, 3, 4, 5, 6, 7, 8. Sigma is 8, pi is 1 and 2. So your answer was incorrect. See, you need to first know how to open up this structure. There is a double bond in C double bond or single bond OH. So those who got this answer, they are correct. Okay, next one.
So 9 sigma bonds and 9 pi bonds.
9 sigma, 9 pi. Okay, let's try. C double bond C triple bond N, C triple bond N, C triple bond N, C triple bond N. Okay. Here sigma, 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 sigma. Sigma, 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 and sigma. How much sigma is there now? 1, 2, 3, 4, 5, 6, 7, 8, 9. Sigma is 9. Pi. 2 pi here. Pi, 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 pi. 1 pi here. 2 pi here. 2 pi here. 2, 4, 5, 6, 7, 8, 9. Okay. Now this one is correct. 9 sigma and 9 pi bond.
Pi bond.
Okay. Let's start with the quantum theory of covalent bond. This is important. Just listen very carefully. Quantum theory of the covalent bond. Okay. So, if you know that I told you one thing, that energy is inversely proportional to the stability. Okay. So every system has a tendency to acquire the minimum energy state. Okay. So what exactly happened? There is a when when there is the formation of covalent bond, the potential energy in the starting. When there is the formation of covalent bond, the potential energy in the starting start decreasing. And when the potential energy start decreasing, it means the stability of the molecule will start increasing. Condition. The potential energy of the system was decreasing and now the system is having the more stability. This much is clear.
Yes, sir.
So, two conditions. First condition, if potential energy is negative. Second condition, potential energy is positive. If potential energy is negative, it means attractive force will generate. Attractive force will generate. But if potential energy is positive, then repulsive force will generate. So it means if there is a negative potential energy, it means the attractive force is there. If there is a positive energy, it means repulsive force. It means two type of things happen when two type of atom approach each other. When two atoms are approaching each other, it means two things happen. There is an attraction force, there is the repulsion force. And why this is happening? Okay. See, the condition is, I'm talking about two hydrogen atom. Okay. I'm talking about, okay, just take any two hydrogen. Okay, two hydrogen atom. So this is the nucleus of hydrogen. Okay, that is Ze, any positive charge. Another Ze, that is called another positive charge. This is one hydrogen atom. This is another hydrogen atom. Okay, this is the nucleus of hydrogen, this is the nucleus of hydrogen. Now this one is the electron of this hydrogen, Ha, and this is Hb. So this Hb electron is this one. This is Hb electron, this is Ha electron. Okay, two conditions are there. So because if I talk about the hydrogen atom, one electron is present only. So Hb electron is this one, Ha electron is above one. Now what will happen? Now exactly what will happen? I'm showing it with another color. Okay, the atom of the nucleus of Ha will attract the electron of Ha, but since it is positive, it will also attract the electron of Hb when they are coming close to each other. Just because if there is a bonding, it means the atom will come close to each other. Second thing, same goes to the Hb. In the case of Hb, it will attract the electron of Ha, and it itself attract electron of Hb. Now you can say this is attraction force, this is attraction force, this is attraction force, this is attraction force. But if I'll go for the repulsion, there is the repulsion between the nucleus of Ha and the nucleus of Hb. This is repulsive force. Same goes to the repulsion force between the electron of both the hydrogen atom. This is again repulsive force. So it means when two atoms were coming close to each other, there was two things. There were two things. First one is the attraction force, second one is the repulsive force. But condition is, okay, how many repulsive and how many attractive forces are there? You can say na, 4 attractive and 2 repulsive. So condition is for the formation of covalent bond. If I'm talking about the formation of covalent bond, if attractive forces is more than repulsive forces, then only the covalent bond will form. Then there is a possibility of forming the covalent bond when the attractive force is more than the repulsive forces. Clear?
No, sir.
Again,
Sir, once again.
Yeah, sir.
starting, I'm telling from the starting. See, when two atoms are coming close to each other, see, while forming the bond, the atom must be close to each other. Clear with me?
Yes, sir.
When they are coming close to each other, it means the potential energy is for the rest. When any of the things is in rest, it means it is occupying the potential energy. Okay, so the potential, and when they are coming close to each other, when the potential energy is decreasing. And I've told you one thing, that energy is inversely proportional to the stability. So I'm saying potential energy is decreasing. So it means the stability will increase. Clear?
Yes, sir.
So I've write the first point as potential energy is decreasing while the stability will decrease. But two things happen. What happened? See, this is one hydrogen, this is one hydrogen. These hydrogen are coming close to each other, coming towards each other. This hydrogen have nucleus and electron. This hydrogen also have nucleus and electron. Okay, we have learned that same charges repel each other and opposite charges attract each other. Okay, so the electron and electron have same charges, and nucleus have same charges. Nucleus have positive charge and electrons have negative charge. So the same charges will start repelling each other. So this is a sort of repulsive force. But we know one thing, that the electron of hydrogen A, hydrogen B, the electron of hydrogen A will get attracted by the nucleus of hydrogen B. This is the attractive force. Same goes with this this hydrogen will attract its own electron also. This is attraction force. But condition is now the nucleus of this one will also attract the electron of another hydrogen which is coming close to each other. Okay, so this condition I have mentioned here. This is the nucleus. This is the nucleus. Nucleus of one hydrogen attract the electron of another hydrogen and its own electron also. So these are two attractive forces. But if I'll talk about this one, this will attract the hydrogen electron of itself and the electron of another hydrogen. So this is again two attraction force. So 2 or 2, 4. It means 4 attraction forces there and 2 repulsive forces here. I told you the condition, there's a condition if attraction is more. If attraction force is more, then only the covalent bond will form. Just because if they'll not come close to each other, that means the bond will not take place. If they'll do the maximum repulsion, it means they are going apart from each other. If they are going apart from each other, then the condition is they will not form covalent bond. Now clear?
Yes, sir.
If any point is not clear, then tell me the point. I'll explain it again. Just because we need to clear this thing. Okay. So for the condition is for the negative, if potential energy is negative, attractive force was generating. So when condition is when the potential energy is maximum. Remember one condition. One condition is there. I'm making a star. Whenever you want to write it, you can make a star that when the magnitude of attractive force become equal to the repulsive force. The condition is when the magnitude of attractive force become equals to the repulsive force magnitude, the negative value of potential energy is maximum. It means at that particular time it will try to generate the attractive force more. So just remember, condition can be asked. What condition can be asked? The question can be like this, that tell me the condition when the potential energy is maximum, negative maximum. So it can give you 4 points. First is potential energy is the condition is, first condition is attractive force is greater than repulsive force. Second condition is repulsive force is greater than attractive force. Third condition is attractive force is equals to repulsive force. Fourth condition is attractive force is equals to 0, repulsive force. Okay, just don't say repulsive force, whatever it is. Attractive force is equals to 0. Okay, which condition? Max condition is maximum negative value of potential energy. Which condition?
Third conditions.
Third one.
Yes.
That is attractive force become equals to the repulsive force. Clear this much? So you don't have to remember. Okay, let's move further. What happens when the electrons are getting closer and closer to each other? Condition is if more closer the atoms are brought, then at that time repulsive force dominates. These are all experimental things. You have to remember that whenever the more close atoms are there, the repulsive force try to dominate itself and the potential energy will start increasing. Let me make a basic graph. Okay. So on the left side, I'm taking as potential energy. On the right side, I'm taking R. R is the distance between the two atoms. Okay. And potential energy you all knows. So I'll make a graph. Just remember the graph. I'll explain it. Okay. So in the starting, when we decrease R, when we are decreasing the R, there is more attractive force than the repulsive force, due to which the potential energy start decreasing. What I said? In the starting, when I'm decreasing the potential energy, when I'm decreasing the distance between the two, then the repulsive force was increasing more. Basically, I'm writing a condition. See, here attractive forces are more than repulsive forces. Why? Because when I'm bringing in the starting, when I'm decreasing the R, when the R is decreasing, what will happen? There is more attractive force than the repulsive force, and the potential energy was decreasing. See, potential energy increasing in this way. So if I'm breaking it downward, it means the potential energy is decreasing. What will happen? There is a condition A. First, I'm writing it as a condition. This condition, just when it acquire the maximum negative value, and the condition is when the maximum negative value is attained. I told you just 1 minute before. When the maximum negative potential energy is obtained, the condition is
A if equal to, attraction force equal to repulsive force. So
yes. So in this condition, I'm saying that the potential energy is maximum negative. So this condition is that the attractive force become equal to the repulsive force. So first condition was when the R was decreasing, attractive force was more than the repulsive force. In A condition, the attractive force become equal to the repulsive force. Now, I told you the third condition, if more and more closer the atoms are brought, then there is a repulsive domination. So, experimenters found that a repulsive force was in dominating and the potential energy was start increasing. So, here, then at this condition, just imagine this is B. In this B condition, repulsive force start dominating the attractive force. Repulsive force start dominating the attractive force, and above the line, attractive force become 0, and only repulsive force remain here. So these are the condition. If we are bringing the two atoms closer, then the repulsive force is maximum. So every time you see as there's a bond between. Why the bond? There must be a minimum distance between the atoms while forming the covalent bond. Why? Because if the condition is if, just imagine A and B, they both are forming the covalent bond. If there is no minimum distance between the A and B, it means the repulsive force will start dominating and this bond will break. See, graph. Just click up, take a screenshot. In the starting, when I was decreasing the R, it means I'm bringing the two atoms closer. The attractive force in the starting was increasing and repulsive force was decreasing. There's a maximum negative value condition obtained. When the potential energy was decreasing, there's a condition obtained that attractive force become equal to the repulsive force. Now what will happen? When I'm bringing more closer to the atom, more atom closer. It means when I'm decreasing more R, it means what will happen? The potential energy start decreasing. It start increasing. And when the potential energy start increasing, the repulsive force start dominating the attractive forces. And when the repulsive force is dominating the attractive force, it means the potential energy will increase rapidly. So this was the only quantum thing. In this all, you don't have to remember a lot of things. You just remembered 3 things here. 3 to 4 things. Conditions. First condition, what you have to remember, when the potential energy is decreasing, the stability will increase. First. Second thing, what you have to remember is two things occur. That is attraction force generate होते हैं, and attraction force generate, and second condition is repulsive force generate. When attractive force will generate when potential energy is negative. When repulsive force will generate when potential energy is positive. Okay. Third thing, what you have to remember, when attractive force is more than the repulsive force, then the covalent bond formation takes place. When attractive force is more than covalent bond, then only the covalent bond takes place. Fourth condition, when negative maximum potential energy is there, it means the magnitude of force is equals to attractive force is equals to the magnitude of repulsive force condition. Next condition, what you have to remember, if atoms are bringing more close, it means the repulsive forces start dominating. There's no necessity to remember this particular graph. Just remember these condition only. On the basis of this condition, you can do easily the numericals. Okay. Now anything you want to ask? From sigma pi to this quantum. And remember one thing, tomorrow I'll ask the difference between the sigma and pi bond. Tomorrow I will definitely ask about the repulsive force, attractive forces condition. And when will attractive force generate, when will the repulsive force will generate? I will ask. So just remember, you have to revise it once. You want to ask anything? Anyone? Just 5 conditions, okay? First one, second one, third one, fourth one, and this fifth one. No need to remember this graph. It's just for understanding. But if you're feeling this as tough, then leave it. This is a quite important, but not for your that much, just because you'll not get any question from here. You can get the question from the 5 points only. And condition is if only the attractive force is max more, then repulsive force must be less, and then the possibility of covalent bond will be there. Okay. So in next class, I will start with the hybridization. Okay. And with the hybridization, and then I'll go for the VS-EPR. No, I'll leave the VS. No, I'll go for the VS-EPR then. Hybridization, VS-EPR, and hydrogen bonding. I'll go for these 3 things first. And then last topic, MOT. So probably by the end of this week, we'll complete this particular chapter. And at the end of this particular week, what I'll do, I'll send you some questions. Okay. And you need to do that particular question. If you have any doubt, you can ask me in the Monday class then. Tomorrow I'll start with the VS-EPR and the hybridization. Okay.
Yes, sir.
Okay. So I'll send you this thing also. So happy Teachers Day to every teacher here and to every student also.
Happy
Just because
Teachers Day.
we'll learn each other lot. Whenever we talk, we used to learn something from each other. So I'm wishing you also a happy Teachers Day, and to the teachers which are in this meeting, happy Teachers Day to you all.
Thank you so much, sir. Wish you the same, sir. Happy Teachers Day.
Same to you, sir.
Thank you so much. You can join, students, you can join the next session. Thank you so much.